All right. Hello, and welcome to this Scratch Lab session. I'm Eric Rosenbaum, product manager at Scratch, and I lead the Scratch Lab. And we have Mimi as well.
Hi, I'm Mimi. I'm the designer with the Scratch Foundation. And we also have a few other people joining us today. If everybody in the fishbowl wants to introduce your name and your role in organization and popcorn it to the next person. So I'll send it to Ariam first.
Hey everyone, my name is Ariam. I'm a design educator and I work at the Stanford Design School to create resources around emerging technologies for students and teachers. And I will pass it to Aaron.
Hi, I'm Aaron Reuland. I'm a library media teacher in Norwood, Massachusetts, and I'm very active on Twitter and Scratch. And I will pass it to Ryoko.
Hi everyone, my name is Ryoko. I work as a museum educator in the tinkering studio at the Exploratorium, San Francisco. And I'll pass it to Robbie.
Hi guys, I'm Robbie. I founded Kiddo Byte to teach free coding classes to kids in the Boston area and then really everywhere now. And I'm very excited to get started.
Cool. It's great to have our participants here live and also everybody watching and using the chat. It's super exciting to see. Let's do the icebreaker question via the chat. If you could transform into any creature, what would you transform into? And that's just a teaser for what we're about to play with together in Scratch Lab. So while you think about your creatures and put them in the chat, what even is Scratch Lab? So Scratch Lab is our place for the Scratch team to develop new experimental features that extend what's possible for Scratch, new creative possibilities. And in some cases, we share them with the public so we can get feedback. But as you'll see today, not everything is ready to share. So you'll see some early work. And now Mimi will give you an overview for today.
Yeah, so today we're going to explore some of the Scratch Labs that are out and a more experimental thing that we're trying out that is not shared as a Scratch Lab yet. So we'll be starting with face sensing and then trying out a new physics extension. And then we'll have some time for Q&A at the very end. And our lovely participants here will be helping us throughout and trying out both of these extensions.
Yes,
so I'll pass it back to Eric.
Thanks. We invite our folks participating to create along, and then optionally you can share your work in progress. It's all going to happen quick. So let me just share my screen. One more second. There we go. So this is the Scratch Lab homepage at lab.scratch.mit.edu. There should be a link on the conference session page. And this shows the two currently available Scratch Lab sites. So we're going to play with this first one, face sensing, but also be sure to check out animated text. Play with words in new ways in Scratch. It's really fun. But so let's dive in to face sensing. So there's a page here with a little video and you can click try it out. If you scroll down, there's more info, things to try, starter projects. But let's just go right in and try it out. And while that loads up, there we go. So face sensing loads your live camera image on the stage and allows you to make sprites interact with your face. What? For example, stick to your face. Why would you want to do that? Hopefully you'll see in a moment. But if I just click on this first block, go to nose, you could see the cat jumped to my face. If I move my face and click again, it just jumps to me. Okay, so let's make that happen over and over again. We can use the scratch block called forever. And now it just repeatedly goes to my nose and follows me around. So I have the scratch cat stuck to my face. So you can start to imagine here, we can make things a little bit like the filters for video that kids use on various apps, social apps, to make costumes, design fashion things. And that's of course why I mentioned becoming a creature. So let's get, I think I want to put a cat nose on my nose. So instead of the cat, I'll paint a new costume here. So I switch to the costume editor. Now I'll just grab the paintbrush here and draw a little cat nose. Now, I don't know if you can see that. It is on my nose. It's a little small. So I'm just going to select that and make it bigger. And I have to make sure that it's centered so that it sticks properly to my nose. Oh, that's pretty cute. Let's go even bigger. So already I'm transforming, but I think I'm missing some whiskers. So let's try that. All right, I'm just going to draw some whiskers. Those are kind of long, but they're definitely whiskery. All right, that's pretty cute. Now I'll select those and click copy and flip. And now, whoops, I forgot to paste. Let's try that again. Copy, paste, and flip. Okay, so now I have two sets of whiskers. And as you can see, they follow my face around. That's pretty nice. But there's a funny problem, which is as I rotate, the whiskers don't follow me. But we can fix that with code. So if we go back to our face sensing blocks, there's a block called point in direction of face tilt. And if I just drop that in the loop, now every time through the loop, it's sticking the nose to my nose and then changing the angle so that it follows my head as I tilt back and forth. Let's do another piece of my creature costume. So for this, I'm going to add another sprite and click paint. I think I want to try to make some cat ears. So just draw a little triangle. Fill that in. Maybe I'll just use my same duplicate trick. So copy, paste, flip. Now I got two ears. So they're not stuck to my face yet. I got to add some code. So we'll do forever, go to nose, and then click to run that. Now, I don't want them to stick to my nose, but I can choose my mouth or my eyes, and there's an option called top of head. That's pretty good, actually. They went right to the top of my head. And you can see they have that same problem. So I need tilt. Cool. So I'm already like a little bit of a creature. Now there's one more thing that we can fix, which is you can see as I get further back or closer up, it doesn't really change size. So we can use this set size to face size block. And now they're way too big. Common problem, ears too big. So I can just scale those down till they look like they're about the right size in the paint editor here, and remember to center them. And now, at least for the ears, as I get closer, they get bigger, and as I go further back, they get smaller. So let's do that same process for my nose and whiskers. Too big, so I'll scale them down. And now, meow, 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 meow. As you can see, my cat costume is so realistic, I speak cat now. Why don't I pause there and see if there are questions. Hopefully Mimi's been able to monitor the chat a little bit, or if any of our fishbowl participants have any thoughts or questions.
I was just wondering if there was some way you could do the scaling in the code somewhere. Would that be possible? Because yeah.
It is. So there is the change size and set size blocks. So what this set size block doing is setting the size to something in particular. And so if after that we set it again, it will just change. So now it's always just going to be 100%. If I do change, it'll be relative. So I could have, fair point, Aaron, I could have, instead of manually changing the costume in the costume editor, I could have just done change size by -50 or something, and that would change the relative size. And actually, I kind of like that. Have a slightly smaller set of whiskers. It's working. And of course, you can put other blocks in there too. So every time through the loop, what if we change the color? Whoa, it's like flashing. Let's maybe get a slower color change. That's pretty nice. Any other ideas or questions? So now is our fishbowl participants' chance to create along and try making stuff, which you'll have the option to share. And so while we give them a few minutes to do that, I thought we might show some other examples of things that you can create with face sensing. Sometimes, I'll just stop sharing for a second here. Sometimes on a video call, you can see people start to like bob their heads around, which is always a good sign that they're testing what they're making. So I love to see that. Are we getting anything in the chat yet?
Not specifically about face sensing quite yet.
Oh, I see Colleen has made a project. That's awesome. All right. So we're doing pretty good on time. So let me show some starter projects and also community examples. In just a second. Okay, I'll share my screen again.
Oh, Eric, there's a quick question in the chat.
Yeah.
Somebody wants to know if there's any plans for opening the extension interface for others to create their own extensions.
That's a great question. And they may be aware that in the past, we had a version for Scratch 2. We're now in Scratch 3, but for Scratch 2, there was a site called ScratchX, and there was an easier way to create your own extension for Scratch 2 through ScratchX. We don't have something similar to that for Scratch 3, but Scratch 3 is open source, and so people can make their own extensions. It's just not as easy as we might like. So we're hoping to make that easier in the future. So let me just go back to the face sensing page here, and we'll show some starter projects. So the hat and glasses, kind of classic face filter for clothing, pretty fun. And then in this case, you can click on your hat, get different hats. I like the bear hat, heart glasses, pretty nice. And the code should look familiar there, same as I was showing before, but with also when clicked next costume. That allows you to just cycle through different things to stick on your face. Here's another one called Flapping Bird. So this is an example of making a game with face sensing. So now, in this case, the bird is just stuck to the top of my head, so I can move it around, and then I try to catch the strawberries with the, oh man, with the bird. And it gets me moving my body around, which is pretty fun. And so you can imagine lots of games that you could create using face sensing that really engage body movement. And then the last example here, the soundboard project. So this is more like an accessibility or assistive technology inspiration, there's a block for when the sprite touches your mouth. And so when this hello sprite touches my mouth, it will change color and
Hello.
say hello.
Hello.
I can say
No. Yes. No.
other words,
Thanks.
or these little ukuleles let me play music with my mouth, or I can get some random sound effects, which is pretty fun. And each of those sprites just has similar simple code in it for when the sprite touches that part of my body. And then I'll quickly share just a second here. Just a few examples of things that we've seen on social media that people shared using face sensing. So this one is painting with your nose. So that's using the stamp block in the pen extension so that the sprite follows you around and you can draw with it. I love that. It's drawing a heart there. This person simulated masks. It's a very of the moment kind of project. Different mask designs that stick to your face. And this person riffed on the assistive technology one to show different emotions, such as sad, happy, surprised, teeth, and YouTube. I don't know what YouTube as an emotion is, but I love how expressive that example is. Cool. So at this stage, I want to ask our fishbowl folks if you have any more questions or want to share any work in progress yet.
Yeah, I can go ahead and share what I have
Oh, that'd be awesome. Thank
off
you.
my video. Just give me a sec.
Oh, just a tip. On some Windows computers, it seems that you can't use the camera on Zoom and on face sensing at the same time. So he's just turning off his Zoom camera, and hopefully the face sensing will work for him and he can share with that.
Let me share my screen now. All right, I think everyone can see it. My
I'm
code. Sorry.
I'm excited.
Yes, my code is pretty simple, just like Eric had in the beginning. I think the difference really came into the costumes. It's currently not running, so that's why it's not working. But if I click the green flag, this dragon should be following me around, and then he's flying a little bit with the wings. That's just in costumes, changing the wings slightly, their direction back and forth, and the dragon is sort of following me. Yeah. In further iterations, I would change the fire as well and maybe neck position.
I love it. You get to be a dragon.
Yeah.
It's such a nice animation too. It's really expressive and simple at the same time.
Thank you.
Any suggestions for how Robbie could take that project further?
Sound would be cool.
Oh,
Well, I'll get
oh,
on that.
oh my.
I will get on that now.
One thing I like to use is a feature of the face sensing blocks for when you tilt your head to one side or the other. And so you could maybe like breathe fire or breathe fire.
Right.
When you tilt.
And maybe switch the neck from one side to the other depending on which way you're facing.
Oh yeah, that's an interesting idea. The face sensing concept is very face front. It does not really deal well with sideways.
Yeah.
Like this, but
That's
tilting
true.
like
But
this.
I mean, exactly like this. That changes the neck position.
Just want to give
People are
a shout out to our
suggesting-
ASL interpreter. Thank you for your hard work following this strange conversation.
Some people are suggesting the dragon breathing fire, changing backgrounds, using your ceiling fan to trigger a sprite motion, breathing fire when you open your mouth, having a little night join. Lots of suggestions from the chat.
I love
Cool.
the ceiling fan one. I wonder if we can make if they said have a ceiling fan trigger sprite motion. I'm not quite sure if that's possible right now, but it's something Scratch should work on. Detecting ceiling
So
fan.
there's an existing extension in Scratch called video sensing, and that is different from face sensing. It just detects motion on the camera. And so it might be able to detect your ceiling fan, but it wouldn't be able to detect your face. And then the question is, could you combine the two extensions? So that's an interesting thought. Other participants want to share?
I can share something. Oh, sorry, Yoko, do you want to go?
Oh, no, go ahead, please.
Right.
Mine is very simple.
Yeah. Yeah, if I can share my screen, let's see. I think I should be able to do both. Oh no. Oh. Maybe Braille could go next because I'm having trouble sharing my screen.
Sure. Okay, let me try mine. So I was trying to become, see my screen?
Yes.
Right. It's not quite working. I was trying to become a penguin. So I just grabbed a penguin mouth from the sprite. And is it following? No. I don't know why.
Classic bug.
What did I do?
So I think I see what's happening. In your forever loop, it goes to your mouth, but then there's another loop with a wait statement. So it goes to your mouth once and then it animates. And then it's going to go to your mouth again, but only later.
Okay, so should I remove it? Then I wanted to make it like talk.
Yeah. So one way to do that would be to have a second forever loop going at the same time. So instead of that repeat, if you just have another forever loop that starts at the same time as the other one.
Oh yeah, that's true. Another thing I wanted to try, just inspired by the animation where Aaron was in the making faces, talking about feeling and emotion. So I added this like, blushing.
Oh, that's awesome. It's so realistic.
I don't know if that's just look like penguin blushing, but somehow trying to combine this emotion with your own.
Oh, that's amazing. Using face sensing to express emotions in new ways. I love how it was a kind of transparent gradient, so it really looked like it was on your face. Ah.
Yeah, I just got inspired by your audio session.
I love the combining of ideas across the Scratch conference. So good. How's it going, Aaron? Are you having technical difficulties?
I'm having technical difficulties. My Chrome browser won't allow me to share my screen for some reason, but I'll try. I think there's some privacy setting I got to figure out.
It's a Mac preferences thing. Sorry about that. Do you want to just briefly say what you're working on?
Yeah, absolutely. So I was at the making facing session last session. So I gathered some materials in the yard to make pine cones for eyebrows and stone for nose. And I'm trying to get them all to stick to my face and then actually blank out my screen with the face, with the video sensing. You could take down the transparency of the face. So it's just the thing showing.
So your face is kind of puppeteering a whole other.
Exactly. That was my idea. And as soon as I can get it to work or show,
it looks like
maybe I could post a video. Yeah.
Yeah, it looks like people are posting screenshots in the chat too. Thanks for doing that. That's awesome. I see a cat face in there, for instance. Really fun. All right, so we just have a couple minutes before we switch over to the next thing. Ariam, did you want to share or talk about what you're working on?
Sure. So I was just like experimenting with a couple things. I kind of just copied you, Eric, as like just to practice. And then I was like, ooh, it'd be fun if I had like little devil ears. And then
whoa.
And and then it's always cold in the Bay Area. At least it's cold for me. So I wish the sun would like follow me. So I was like, it'd be kind of cool if that was happening. But then I guess that. Like I'd have it like over my head, I guess, top of head.
Mm-hmm.
So you can't really see it, but Yeah, so I'm just experimenting with the different costumes.
Really nice. Also, I'm impressed by the level we got to so fast. Thank you to our fishbowl participants for diving in and doing things quickly. It's super cool to see. So let me just share one more example with another funny idea. I called this project Say It and Spray It. It uses the loudness block, which is in the sensing category. If I check the box off for that one, you can see the numbers changing as I talk. It's measuring the loudness from the microphone. So combining that with face sensing allows me to shoot out sprites as I talk. And the different things are not related to the words that I say. So like, if I talk about bananas, I got apples instead. Anyway, it's a project that uses clones to make copies of a sprite, and they all just go to the mouth and then move away. And they use loudness to set their size. So just a fun little experiment. Cool. So let's see if there's any other questions to address here.
Yeah, Eric, there is some questions about security and compliance. I think COPPA compliance and GDPR for Europe.
Great. So we do address stuff about safety and privacy on the face sensing page. But I can say that the face sensing technology runs on your own computer. So we don't send pictures of anyone anywhere. They're not stored anywhere. It's all running locally on your computer. So hopefully that addresses most of the safety and privacy concern about face sensing. But yeah, like I said, you can read more on the face sensing page. And there's a whole blog post that we wrote about another set of concerns around machine learning and algorithmic bias. So that's the question of whether the detection of faces is fair. And that's a hard problem, and it's not perfect, but we were able to reach a good enough level of confidence in the technology that we chose because it had been evaluated specifically for differences across geographic regions. That said, there's a long way to go in transparency for that technology and making sure that things are safe and fair for everyone to use. But yeah, check out our blog post for our thoughts on that. Oh, maybe we have an update from Robbie on a version 2 Dragon. I'd love to see quickly, and then we're going to shift over to the other extension we're going to play with.
So just a few suggestions that we had. I also like the idea of a knight being underneath. So I have the knight sort of running away from me, and I have this dragon whose head switches sides whenever I turn my head. I'm trying to get this guy. Now I should make him point down too at some point, but right now I'm just sort of failing to kill this knight. No.
It's very expressive. Cool. All right, I'm just looking in the chat again to see what else. There's so many people have lots of interesting questions and ideas about this. We do not support QR codes in this version, but that's an interesting thought. We do not, unfortunately, have it available in the desktop version. Scratch Lab is just in the web-based version. Somebody's stuck on loading extension. That likely means that their computer or web browser in some way is not compatible with the face sensing technology. That's one of the reasons that face sensing is still in Scratch Lab instead of the main version of Scratch, because the compatibility across, we want it to be available to everyone that uses Scratch, but the compatibility is not perfect yet. And another issue is performance, like how fast it runs. We'd like to improve that before it would be ready for everyone to use. Oh my gosh, there's definitely scroll through this chat to see people's cat faces and other costumes. It's pretty hilarious. Um,
Love seeing all the photos.
cool. All right. I think we're okay on that one for now. Whew. Thanks for doing face sensing, folks. Mimi, are you feeling ready to jump over to our next thing?
Yes, I'm ready.
Sweet.
I'm gonna go ahead and share my screen.
All right, so this is an experimental prototype. Face sensing has reached the level of stability where we were ready to put it on Scratch Lab. This is it's called the physics extension, and it is not done yet. It has bugs. It's kind of weird, but it's like interesting to play with, and we'd love to learn more about it as we try it and see what's possible. I'm just going to share this URL, which is a temporary URL, with our fishbowl participants so they can try it out. I definitely don't want this to spread widely for the reasons I said. It's not fully up to Scratch standards as an experience, so we're not making this public, but we're just giving you a sneak peek of something we've been playing with. Okay, so now Mimi's got those physics blocks loaded, and we can make some suggestions as she pokes around and discovers things and tries things out.
I'm just going to go ahead and start with the very first block, which is turn physics on. So I'm just going to click it.
What happened there?
Scratch Cat is bouncing around. Well, Scratch Cat kind of just dropped to the ground. They're a little bouncy a bit if I pick them up and I drop them. There's now gravity essentially.
Yeah.
I can throw a Scratch Cat, kind of toss them around and spin.
So Scratch Cat bounces a little bit.
Yeah, a little bouncy. Kind of wonder if I can make Scratch Cat a little bouncier. Maybe let me try push. I'm just gonna click it. I'm not gonna put any blocks together. Oh.
So what's happening there?
When I press push, Scratch Cat is like, it's just like Scratch Cat was shoved from the bottom and sent into the air.
Kind of tumbling.
Yeah, it's kind of like, in Mario where you can do a double jump.
Yeah.
If I do a double push, I get a double jump from Scratch Cat.
And so it's worth noting that the motion blocks in Scratch let you move a sprite around. But what we've done here is build in what's called a physics engine that simulates motion of objects and their collisions, and then applied that to the sprites. And so now the sprites kind of move themselves around. So one other thing we might try is just adding another sprite and turning physics on for it.
Yeah. I hope Scratch Cat likes apples. So I'm gonna give them an apple sprite.
So now, when you turn the physics on for the apple, it falls as well. But what if you drop it on top of the cat?
Oh.
It doesn't really balance because the cat is not flat. So it kind of falls off of it and shoves the cat a little bit as well. So things kind of collide.
I wonder what happens. What if
Slides
I
right
have
off.
flies right off? Wonder if I want to be able to have things just bouncing off of each other in here. I want those collisions to happen. How do I make it really chaotic like that, Eric? I just want, what if turn physics on for this state?
And so now oh, go ahead. So yeah, if you use the green flag to turn physics on for both sprites, and you can see that outline appears when the physics is on, and that shows you the collision boundary for the sprites that it calculates. It's like its outline for the physics.
Yeah. I kind of want to like spice it up a little bit. What if I started making clones?
And this is pretty funny. So normally when you click the clone block, it makes an identical copy of a sprite in the same position and rotation, the same exact spot. But with the physics extension enabled, if a sprite already has the physics turned on, its clone will also have physics, and they can't occupy the same spot, so they'll push apart. And so as soon as you click create clone, you can just click it once just to show that. You'll get a second sprite, in this case on top of the apple, and you can keep clicking that and you'll get a pile of apples. And this is again something that feels quite distinct from what happens normally in Scratch, because now you have a little sea of apples all smushing together. And now it gets a little out of control, too many apples, but that's fun.
What if I wanted the apples to like, I don't know, like move around a little bit more?
And
I'm gonna try. What is setting the graph speed? Like what happens when I set the graph speed to 0%? Oh.
So yeah, I was just answering a question in the chat about when the link and when this will be available, and unfortunately, we're not ready to make it publicly available yet. So it's just a sneak peek. Whoa, Mimi, that's a lot of apples.
It's just a few. Just a few.
I like them apples. Apple packing, yes.
I want the apples to, be able to move around a little bit more. So I'm gonna.
Oh yeah, so when you press a key, you use the push. Oh, they're kind of jumping each time you press the key. Plus you're getting more clones.
Yeah.
Whoa, it's like popcorn or something. They're boing, popping. That's nice.
I want them to float a little bit more. Now it's almost zero gravity.
So how are our fishbowl participants doing? Are you folks playing around with the physics? Have any questions or ideas or want to share something?
No, it seems like a great tool to try to do like a sort of platforming game where you don't really have to hand code all the physics and it would take a long time. This could be a nice, it'd be really realistic physics and neat. Yeah. I've got something going on my screen. It's fun.
Cool. Did you want to share?
I could try. Yeah, I could try to do this again. No, someone's sharing, so I gotta wait to.
Oh yeah. So Mimi. Okay, thanks.
I'll try this. There, is it coming up?
Yeah, looks great.
Pop, 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 and then you can bump them around. Try to get them up on the platform as many as you can.
Oh, nice. So you've used the lock to stage option to keep that purple platform in place.
Yeah, and then you touch that. If you click on them, they'll spin. So you can try to maneuver them a little more, and nudging in all the different directions with the different arrow keys.
I love it.
Yeah.
So one thing I've noticed is that the way people code platformers on Scratch really relies on being able to control, I think, something like friction. And that I don't have blocks for that in the physics extension yet. And so everything is super slippery. And so it makes it a little hard to control. Also just generally like having a control of something like density. And again, this gets into concepts that are like not quite at that low floor of simplicity and understandability that we normally want to get to with Scratch. And so the question is how to balance out making it possible to do all of these powerful, cool things, but also making it not alienate people with technical language. So I tried to do that in the wording of the blocks that are already there, and you can imagine wanting lots more features. Let me quickly show you a few things that I've been playing around with it. One of the things that we do as part of trying to develop new features is just try them out and play ourselves a lot, in addition to sharing with other people on the team and then outside the team. And eventually, once it's working well enough with kids, I would say this physics thing is not ready for kids yet because there are a lot of problems with it. Here, for example, is a kind of marble run project. So if you look at the ball sprite, it's just creating clones which fall. But then this purple sprite, I can rotate, and then if I click, it locks it on, and now I can kind of make a little track for the ball to bounce on, and then I'll try to get it to go all the way back over to the star. Whoops. Oh no, I might have to start over again. Try to bounce it that way. Oh, almost. Get right in the path there. Cool, and so then the star detects the collision, it spins. You can also, have the balls leave a trail using the pen extension, so you can see the bouncing happen. Whoops. So just making little machines is pretty fun. And then I was also thinking about if people remember the classic game Angry Birds, where you could launch something into a tower and knock it over. So here, as I click repeatedly, I'm making clones that stack into a little tower, and then I can use the arrow keys to control my banana and knock it over. And it's very easy to knock it over because of that friction situation I was talking about before. But what if, and if I press a key here, I can get different shaped blocks, and we can make a kind of game. So if I press P, whoops, oh no, my pufferfish fell over. I wanted to make it so you try to knock the pufferfish off the tower. But again, it's that stability and friction issue. Let's try to just drop it gently on the tower. Oh no, it's fallen over anyway. And then it pops when it hits the ground. So you get the idea. It's like tricky to balance out the forces and friction and make things stable. And one other example. This is a billiards game. So here I've turned the gravity to 0. So now it's more like we're looking top down at a billiards table, although they're actually baseballs. And then if I click, that will push the sprite. So it's like hitting the ball with a pool cue. And I don't have any pockets for the balls to go into, but you can see how already it's got all of the collision physics so that I can knock the balls around. And that's with almost no code in the project, which is pretty nice. Okay. Anybody want to share?
Really quickly, there was a question that if people could be shown the code for behind the scenes that powers these physics commands. They just want to see how much the buttons have eliminated.
That's interesting. So there's a lot of magic under the hood in many aspects of Scratch, and this is one of them. What I did to prototype this was I took an existing, they're called physics engines. So it's not written in Scratch, it's written in the programming language that Scratch is made in, which is JavaScript. The one I use is called Matter.js, but there's many. And it has a lot of code. The nice thing about it is I didn't even need to look at that code. I could just use that and build on top of it. And what it does is complex because it calculates all of this movement and collision and velocities and frictions and things. And coding is often like that. You build a system on top of another system. Other questions coming up? Oh boy, Jenga in Scratch, that's a good idea. And that's another thing that would really rely on tuning the friction, because that's what Jenga relies on, is having not too little or too much friction between the parts.
There's a lot of really awesome suggestions in the chat, like being able to change the effects, being able to set velocity or direction, or combining it with other extensions to make some really awesome other kinds of projects or opportunities for learning.
Cool. Can you alter the gravitational force? Yes, you can. You can even make it negative so things fall up, which is pretty fun. Somebody mentions that the blocks are not translated. It's true. In Scratch Lab, where things are experimental, we don't have the full localization in place. Rube Goldberg projects, yeah, like machines where one part triggers another part, triggers another part. That's a really fun thing to make.
Oh yeah, a gear system, right? You could do a gear system.
Could you? Whoa.
Could you? I think you could, right?
Maybe.
Try it out.
So have a hinge block. And then you would set the gravity to 0 and hinge something. Or I guess you could keep gravity on and have something like a water wheel. You'd have a sprite falling onto another one and it would make it spin. Yeah, actually that would work. Getting 2 gears to mesh would be relatively hard, but one of the limitations is that the physics engine doesn't use the exact outline of the sprite. It makes a kind of shell around it to simplify. And so the gears, you might not be able to get the teeth. There's a question about making platformers. Is there a way to fix the camera to a sprite to make a platformer with a moving background? That is a very interesting thought and reflects how platformer games often work, so that the sprite stays in the center and the world is moving around behind it. And you can do that with a fairly complex set of Scratch code. But you could also imagine an engine that does that for you, kind of the way the physics blocks do some things for you, but not that. That's intriguing. There's lots of really cool possibilities. One of the things that we try to do is make the things that kids want to do and already are trying to do simpler, so that you can focus on the creative aspects you're interested in, and we can solve some hard problems for you. But it's always a delicate balance because we don't want to take too much of a learning opportunity away.
Somebody's asking, if you use the rotate block, what happens? Does it have a drag or does it stop? If any of the visual participants have used the rotate block in their projects, also be a cool thing to share.
So like if you make something spin, does it ever slow itself down? I guess is the question. I think yes, things do naturally slow down a little bit. There's some friction in the world and some damping. But reasonable question. There's different ways to imagine the physics working.
Now, I'm still working on mine, but I'm just wondering, how do you, well, I guess what is the difference between push 10 and push XY?
Thank you for the question. So, in Scratch, in the core blocks, there's a block called move, and that moves the sprite along its heading. Like a sprite is always facing a particular direction. So like by default, the Scratch Cat is facing to the right, and so if you click move, it moves to the right. But then if you turn it and click move, it will move in that direction. And so the push block applies the force along the direction that the sprite is facing, if that makes sense. But the push XY allows you to just apply a force directly up, no matter what way the sprite is facing, or directly to the side. That's another one of those things that is likely to be confusing for people. So it's like, should we just have one or just have the other? Take some research. Oh yeah, and I'll just say again, since this is just a sneak peek of something experimental, and because of the problems with it, we don't want it widely shared. We're gonna take down, sorry, the version that you're seeing today, probably tomorrow. Sorry about that, everybody. It's great to see the excitement around this. People do have a lot of positive energy around it. Air resistance, yeah, we'd have to code in that probably. Somebody's asking about linkages. So, yeah, there's a lot of really cool things that physics engines can do, such as a linkage would be like if you had one rigid piece and another rigid piece hinged to it, you would move this one and it would cause the other one to move, maybe if it was hinged in place. So you could make whole like scissor mechanisms, or similarly like connect things with springs so that one thing could pull on another thing could pull on another thing. And the question is not, can the technology do that? But it's, can we express that idea in a really simple and understandable way using the language of Scratch? And I think that will take more exploration. It's again that trade-off of like adding complexity to make more things possible, or keeping it simple to make it more welcoming to everyone. We're always trying to find that balance. So I know folks are just seeing this for the first time, but if any Fishbowl folks want to share their experiments.
I am still working.
Cool. Well, oh, go ahead.
I almost have the gears working.
Oh, wow.
But you're right. The packaging, the wrapping is making it a little difficult, but they are moving each other, which is kind of neat.
They are. Whoa.
Yeah. There. Yeah. Here we go. So there's kind of like bouncing off each other. We're starting to move.
Right. That's cool. So you just have used that hinge to stage block and then a spin clockwise block.
Yeah. On space key. Yeah.
And so even though you've got these plus shaped sprites, you could see the outline makes a square or diamond instead. And that's the limitation of the physics engine on the shape. But you can make square gears.
So a little like small, it wouldn't change the packing. No, it wouldn't. All right, no.
No.
That's interesting though.
Yeah,
it's fun.
Yeah, cool. And so like, is that limitation understandable? We're able to show you what the actual outline is that it's using, but that might be frustrating or confusing. Another thing that we could potentially add is locking sprites to each other. So you'd have one sprite that's stuck to another sprite, and then that other sprite hinged to the stage, say, and then they would spin together. So you could kind of construct a gear out of smaller parts. But that's another one of those concepts that's like a little, it gets pretty abstract.
Could you make a double pendulum?
Exactly, yeah.
Yeah.
But then you'd have to be able to specify which part of the other sprite you were sticking your sprite to. And I'm not sure how we would do that. Yeah, stuff is tricky. Not impossible. I should also mention, this is not the only experiment in this direction. Other folks in the Scratch community have built experimental physics extensions as well. Griff Patch is one. He's a famous Scratcher who's made a lot of really cool contributions, including playing with physics. chat again. I see. Oh yeah. Somebody did figure out the link. We shared it on the chat. But yes, we're asking people not to share that link, and it's also going to go away anyway. So sorry about that. And just to be really clear on why, this is only partly working, and it's not designed to our standards of Scratch, and so we just don't want people to have a bad experience with it. So I wouldn't recommend putting it in front of children. But it's great to see the positive energy around it that, you know, could motivate us to work more on it. Cool. Well, we have 5 minutes remaining. Maybe we could open it up to questions generally about Scratch Lab, face sensing, and physics. Or I could very quickly walk us through animated text.
I think earlier on there was a question about the synth extension.
About
they mentioned there was a synth extension for a previous version of Scratch, and if there are any plans to make a new synth extension.
Yeah, for Scratch X on Scratch 2, I did work on a synth extension. In other words, a sound synthesis thing. It was pretty fun and had some flexibility not otherwise provided by Scratch to control the pitch of sounds and apply effects like echo and reverb and filter effects. But I have not attempted to bring that back to Scratch 3. I think there's several issues. One is you can already do a lot with sound in Scratch, so it wasn't clear that that was like adding a big enough new space of possibilities. And the other part is that it was a little bit hard to understand what it was doing because of the technical language and the invisibility of the effects. That said, I love experimenting with sound, so maybe we should return to that area someday too.
And we had some requests for animated text in the chat too, in the few minutes we have left.
Well, we could do like, yeah, one minute on it. I'll just share my screen and show one of the sample projects. So if you're on the lab.scratch.mit.edu site and click animated text, you'll get to the landing page for that. And if you scroll down, you'll see some starter projects. So this creature story one, if I click the green flag, you can see deep in the forest, there lived a creature. And so it's drawing those words using these blocks. And so if I just start a new project, you can see I have the cat here, but if I click show text, the sprite becomes text. And I can, change it to some other text. And then this second block does something similar, but with an effect. So it applies a little rainbow animation or the typing effect. So making one letter appear at a time, inspired by effects that we see in games. And the zoom effect that just makes it start small and get big. And then of course you can control the font and the color and even the shape of the text box and alignment. So just for one other example, if we name an animal, let's get giraffe and name a food, sandwich. It will now draw a little poem or a little story. Surprisingly, the sandwich ate the giraffe, using those blocks. So it stores my answers in variables and then says show text food, and it uses a random font. So there's a whole lot of possibilities for playing with language here. And then the last one is a game and shows how you can just draw the score in a new way. So that number is using show text with a variable to show the score in a pixel font. So that was a super quick overview of animated text, but I'd love for people to get a chance to try that. I think we're out of time. Thank you so much to all of our viewers and our fishbowl participants and Mimi and our interpreters for helping make this session happen.
Thank you, Eric. It was great.
Great. Thanks, folks.
Yeah. Thank you, Eric and Mimi.